Hello, our topic is ratios and proportions. Two concepts go together mathematically. So let's take a look at our pre-lecture notes and the things that you wrote down about them. A relationship or a comparison of two numbers is a ratio. So we have an example here of a true ratio, which is comparing 800 miles to 300 miles. And because the labels match within this ratio simplifies to be 8 to 3. The next example that we have is a rate, and a rate can be used as a ratio. In a rate, we have labels that do not match. So with this time we have 800 miles per 8 hours. We can still simplify the numbers. So 800 divided by 8 is 100. But we have to keep the labels. So we keep the miles per hour in the rate. Both of these can be used mathematically as ratios because they are comparisons of two numbers. And so then we're asked to define a proportion. So a proportion is two equal ratios in a mathematical equation. Let's look at the first example. Now I know I already wrote on this, so I'll write it off to the side, but we have the ratio of 3 to 7, and we have set it equal to the ratio of 12 to y. So this is a proportion, which is two equal ratios or two equal fractions. One method for solving a proportion is called the cross product, or you might have heard it be called cross multiply. When we do cross product or cross multiply, what we do is we multiply diagonally. So this is what my little arrows are pointing to. I take the top of the first fraction, multiply it by the bottom of the second one. So 3 times y equals right here, 3y. Then I multiply on the other diagonal. So I take the top of 12, multiply it diagonally times the 7. That gave the answer here of 84. There is an equal sign between the two numbers or the two products because there was an equal sign in the original problem. I then can divide both sides by 3, and you see my math over here to the side, and when I divide both sides by 3, the 3's cancel on the right hand side to give me y, and 84 divided by 3 is 28. So I know that the y is representing a 28. You may have looked at the original proportion and saw a different way to solve, and there are other ways to solve and they're fine. So you might have noticed that if we're going across here, 3 times 4 equals 12. And so across the bottom, I would need to do the same and take 7 times 4, which would again give me that y is equal to 28. These ideas fall into the concept of proportional reasoning, which was noted in our syllabus as one of the skills in this course. And so either method of solving demonstrates that you can reason with the proportion, reason with equal fractions. Sometimes a proportion is written using the colon like we see here. 4 to 5 is equal to x to 19. This used to be more common, but historically we have moved in math towards the fractions. So my recommendation to you is to rewrite it as a fraction. So you see that here. The first is 4 over 5. The second is x over 19. Again, I solved using the cross product idea. So I took on the first diagonal 4 times 19. That gave me 76. And then I took x times 5. That gave me 5x. To solve, I divided both sides by 5 to get x by itself, and that gave an answer of 15.2. So as you get into the homework, the first thing we're going to do is just to practice the algebra skills of solving a proportion. So I have here two that are a little bit more involved than the ones that we saw in our pre-lecture. We are going to use the cross product idea. So I'm going to take the numerator, the x minus 8, and multiply diagonally times this 4. Writing that down, I have 4. The x minus 8 is a quantity, so I need to use parenthesis x minus 8 as I write that so that that quantity stays together. I put my equal sign, and then I multiply on the other diagonal, so multiplying from the 3 down to the x plus 2. Similarly, I have to write that using parentheses, keeping the quantity x plus 2 together. Now, I have an equation, and we remember from the previous week that in equation solving, our first step is distributive property. So I'm going to distribute the 4. So I get 4x minus 32, and you're welcome to use your calculator for any of those math facts you don't recall. Keep my equal sign and distribute on the right-hand side as well. So 3x and then 3 times 2 plus 6. Again, I'm reviewing those equation solving skills from the previous week, which told me to gather my variable terms using addition and subtraction. So I will subtract 3x, doing the opposite on both sides. On the left, 4 minus 3 is 1, so I have 1x minus 32 is equal to 6. My next step is to gather my constant terms. So since I have a subtraction, I will do the opposite. So I will add 32 to both sides of the equal. So my x remains. I am not going to write the 1 in front of it because that is understood. My 32 negative and positive cancel out. So I have x equals, I do the math here, and have 38. So MyLab will have you practice some of these that are, we don't have a word problem, we don't have to create the proportion, but we have equal fractions and we have to be able to solve them algebraically. So if you're feeling confident, I would encourage you to pause the video here and try the next example on your own. If we were together in person, I would have you try this example on your own. I am going to do the example for you so you can see all the steps and check your work. So pause, try it, and then come back to check your work. Because it is a proportion, I'm going to use cross product. So I will multiply diagonally, starting at the numerator on the left and multiplying it by the denominator on the right. So this gives me 3 parenthesis 3x plus 1. I will do the same on the other diagonal, so this gives me 5 parenthesis 2x minus 9. Then my next step is the distributive property, and so I put my arrows here. I have 9x plus 3 when I distribute on the left. Put my arrows here, and I have 10x minus 45 when I distribute on the right. I want to gather my variable terms, and so I'm going to subtract 9x from both sides. I'm picking the 9x because it's the smaller of the two variable terms, and that will get me to a positive value for x. So the 9x's cancel. I have 3 equals. 10 minus 9 is x. It's a 1x, so I'm just going to write x. I will not write the coefficient. I have the minus 45. My next step is to get my constant terms together, so I will add 45 to both sides. And I'm wanting to move those constant terms away from the variables, so that's why I am getting rid of the 45. That cancels, so I have x by itself. And on this side, 3 plus 45 is 48. So I'm hopeful that you got the exact same answer that I did. And these are just 2 examples of solving a proportion using that cross multiply or cross product property.